In this video, we will look at fitting allowance calculations for socket weld fittings and a simple method of setting the expansion gap. The fitting allowance calculations for socket weld fittings are similar to those already discussed for threaded fittings, which also apply to soldered fittings, as all of these have a length of pipe or tube that goes into the fitting. So the fitting allowance will be the face to center or throw measurement minus the insertion depth of the pipe. The only difference is we need to make an allowance for a 1/16 inch or 1.5 millimeter expansion gap that must be left between the end of the pipe and the bottom of the socket. The initial process is the same as our threaded fitting calculations. Here I have a 2-inch 3,000 pound socket weld T. The throw for both the runs and the branch is the same, about 58 millimeters. The insertion depth is 20 millimeters, so the fitting allowance would be 58 minus 20 equaling 38 millimeters. But the pipe will only be inserted into the fitting about 18 or 19 millimeters when you consider the expansion gap that we have to leave. So you could change the insertion depth measurement, or I just typically deduct an extra 1.5 millimeters for each welded connection. Typically there would be 2 connections for a center to center dimension, so deduct an extra 3 millimeters from your end to end length for the gaps. Now that was all pretty much review of the threaded pipe fitting allowance process other than the expansion gap. I'd like to talk now about setting that gap. The gap is too small to try and slide the fitting out of the socket to set it. You would have difficulty being consistent without marking the pipe, which of course takes time. The other thing that you have to account for when tack welding fittings is the cooling contraction or pulling of the weld that takes place. There is a simple way to get a relatively consistent gap quickly that works well, that also accommodates for the weld contraction. Your first 2 tacks should be placed onto the heel and throat of the fitting. The sides will be tacked last. Before you make your first tack though, open the fitting up on the side location where you'll be placing the first tack. You can see that this has set the fitting off square. That's okay, this is what you want. Here's what the bottom location looks like on the outside and inside. Notice it is tight, no gaps. Whereas here on the top you can see that we have created a gap about 1/16 of an inch. This is going to be the location of our first tack weld. Once we have made our first tack on the top, immediately pull the bottom or closed side of the fitting out to the square position as it cools. It'll have a natural tendency to want to move this way anyhow, as the tack will be contracting and pulling a little bit as it cools. Here, the pipe is squared up with the 1 tack. I want to talk about the weld pulling process that you feel. If we had not opened up that side where we placed our first tack, the weld would have pulled us out of square and the fitting would be bound out of square. Notice that this procedure has opened the inside bottom, shown on the left. So we now have a small even expansion gap of about 1/16 of an inch or 1.5 millimeters all the way around the inside of the fitting. Now we're ready to spin the pipe and place the second tack on the opposite side. We finish by checking the sides for square and tap one side or the other if you need to adjust it. If it is just out slightly, I will tack weld the more open side first, and when it cools it will pull it to square. For the first pipe connection into an elbow or T, I'll pretty much rely on my eyeball for squaring things up. I will get more precise when I add another branch pipe and then square the two pipes to each other. I think you will find this technique speeds up the socket weld fabrication process and makes for consistent expansion gaps and accurate fitting allowance calculations.